really far behind because of the holiday and because of that lab. I did lecture a little bit that Wednesday. So I'll review a little bit and I'll try to get us caught up to where we should be. Realize 2 weeks from now I have the test schedule, and there's not too many people I see that have been doing these. I've added a lot here, and I'll open these up. But if you look at the quizzes, you'll see at the top of your quiz, practice for test 1, pure math. That's the significant figures, multiplication, division, subtraction, the scientific notation. And then the next one you see here is, this is just organized better, rather than everything stuck together. Practice for test 1, conversions and calculations. So those are all here. And still, you can see only 6 out of 6. And if somebody, you can do these as many as you want. If somebody did it more than once, it's counting that person more than once. So obviously not a lot of y'all have done it. But we've been really disrupted time-wise. So I guess I'm saying it's time to get onto these things. Things just about the atom are here. I'll go over isotopes today. We did go over ion compounds and formulas and naming. I'll go over covalent compounds and naming. The way you formulate covalent compounds will probably be test 2. Stuff about the mole is here, and hopefully I'll get to reactions today and that'll just about have us caught up to where we should be. My Monday, Wednesday, Friday class is caught up because they didn't get as disrupted as we did because it's a shorter class. So we missed nearly 3 hours of lecture that Monday. And we missed a lot of lecture because of the quiz. I mean, because of the lab. So, any questions on anything we've covered at this point? Any of these you want me to hit? All right, well, let me.
When is the first test?
The 22nd is the way I have it scheduled, which is 2 weeks from now. So here we are on the 8th. Next Monday is the 15th, and then the 22nd is the way I have it scheduled now.
Thank you.
And I think we'll be on schedule for it. Just be sure to go through these quizzes. The test I make will literally be made from questions just like the ones on here. They won't be identical, but they'll be similar. All right. So let's look at as far as the review. Don't have a periodic table to work from. I'll have to bring up a periodic table.
Professor Henry,
Yeah,
when are you going to go with the lab notebooks?
I don't know yet. I'll give you plenty of warning.
Yes, sir. Thank you.
I need to post our tentative lab schedule. I don't think we'll have another lab for a while. As I look at the periodic table. Watching a movie, you can't see this, but if you bring up your periodic table. All right, gallium. Determine the number of electrons and protons in gallium plus. Electrons and protons. Gallium is
31. It's under aluminum.
gallium. So there's gallium right there. So how many protons does it have?
31.
It has 31. It always has 31. That never changes. So you just look for atomic number 31. It's gallium plus though, so how many electrons does it have?
32. 32.
That would make it -1.
31.
39. 30. Well, I don't know.
If it loses 1 electron, that's how it gets a positive charge. If it loses that 1 negative charge, that leaves it with an extra positive charge.
But I thought with the atomic mass would have more. being 69? Because isn't atomic mass proton and electrons? Because I thought neutrons had no weight.
Electrons have no.
Yeah, so with the atomic mass being 39, wouldn't it?
Well,
the
this isn't
electron-
asking for the atomic mass.
I know, but like, doesn't the atomic mass equal protons plus electrons?
Protons plus neutrons.
Oh, okay,
Electrons have essentially no weight.
okay. Gotcha.
I'll cover more details about the avenue test too. We're just sort of covering the basics here. What else should we do in here? The atomic mass for cadmium. This is just seeing if we can use the periodic table. Where's cadmium? There it is. So what's the atomic mass of cadmium? This is the atomic mass, 112.41. So that's just testing your ability to use the periodic table. Atom of bromine. Bromine contains how many protons? If I go to bromine,
35.
it's 35 necessarily. Doesn't matter if it's bromine negative or bromine, it's going to have 35. Electrons, if it's neutral bromine, it'll have 35 electrons. If it's Br negative,
36.
it'll have an extra electron. 36. Okay, so just to get you up to speed on that. The other thing I have under the atom here, the atom is isotopes. This is where we involve the neutrons. Okay. There's two different ways we indicate neutrons. So the other thing that's in the nucleus is neutrons. And when we talk about isotopes, that's when we consider neutrons. So if you see a symbol like this, first of all, that symbol Ag, that silver, it's really redundant to give the symbol and this. If you find Ag on the periodic table, silver right here, it says 47, that's the atomic number, that's synonymous with Ag. So that's really redundant. I don't know why the symbol is like that. The other way you might see this is Ag dash, I don't know. This is called the mass number. And this is just the number of protons. You could put the charge here. Sometimes you see it that way if it's a charged atom. The mass number equals neutrons plus protons. So you might get a question like this: how many neutrons does this isotope of silver have? And all you have to do is subtract 47 from this upper number. Can anybody do that in their head? 9 minus 7 is 2, 10 minus 4 is 6. The neutrons in that isotope of Ag is 62. Is that what that was asking?
Yes.
Yeah, neutrons 62. So protons 47, neutrons 62, and there's no charge there, so it's going to be 47 here. I think that's got to be the right answer. This is missing something here. I can edit that one. Nickel 59. So how many neutrons are in nickel 59? You might see it like this. In I-59. 59 is the mass number. If we go down to nickel, right here, it's 28 protons. So you look at the periodic table and you know it's 28 protons. That's what I said, 28. You subtract 28 from 59. That's the number of neutrons. The whole point with isotopes is, for silver, for instance, the atomic number tells you how many protons, and that's always how many protons it will be. Silver can lose one electron to become positive 1. But it's very slightly the neutrons in it. There's a handful of different isotopes with slightly different numbers of neutrons. So that's what isotopes are. And if you understood what I just described there, I think you can answer all of these. It really is just that. I'll try to remember to bring that back up. Okay, how many protons and neutrons in AC 27 and 80? How many protons, how many neutrons? First of all, how many protons is in this without even looking at the periodic table? 89, that's the number of protons. And how do you find the number of neutrons? Just subtract it from that. I can tell I'm not going to do that in my head correctly. Minus 89. So there are 138 neutrons. It really is that simple. And you might also see this as AC different way. This is probably better because, like I said before, the AC and the 89 are redundant. They're always going to go together. So that's the introduction to isotopes. Let me look at this quiz a little more. The mass number is equal to what? Protons and neutrons. The things that are in the nucleus. I don't know. It's really kind of all there is to it. This is P32. I meant for this one to be one of the isotopes of radon. This should have dash and a number there. So question number 4 is screwed up. So we've talked about ionic compounds and naming ionic compounds and making formulas for ionic compounds. We haven't talked about covalent compounds. How you get a formula for a covalent compound, I haven't gone over yet. But you can learn how to name these. Because for covalent compounds, NO2, I'll just mix it because I want to bring the camera back. Let's see. PCl3. Let's see. N2H2. I'll do H2O because everybody loves that one. This is actually very simple. It's as simple as isotopes, so I won't spend much time on it. This is where you use mono, di, tri, tetra, penta, hexa, etc. Next is hepta, octa, non, deca. We won't go beyond there. This is monophosphorus trichloride. This is dinitrogen dihydride.
Can you put
This-
that camera down?
Sorry. Bring those up just so I can go back to the camera. That's that. This is nitrogen. Hydrogen. This is almost correct. This is that joke where somebody goes around and telling people there's dihydrogen monoxide all over in the environment. Are you against that? Yes, yes, I'll sign your petition. But all they're talking about is water. The common name for this one is water. H2O is water. But this is sort of the technical name for it. The thing is, if it has mono in the front, we just drop it. If this is just one, we drop the mono. So this is phosphorus trichloride. This is dinitrogen dihydride. This is dihydrogen monoxide. So it's really that simple. The first one, you say the whole name. The second one, you say I. There is a more complicated naming system. H6, C3. These are organic. These are organic molecules because they're mostly carbon and hydrogen. There's a whole new naming system for those, but I think you get to those in 1212. So I won't spend much time on that. That's how simple these are. Just remember, this is why I said when we were naming ionic compounds, remember that we never use these for ionic compounds. We never use these for the ionic compounds. We use them for the covalent compounds. Do you remember how you know if something's covalent and ionic? Ionic has metals and non-metals. Covalent is all non-metals. All these here are on the top right of the periodic table, except for hydrogen that is in the top left. And remind me about I can review some stuff on moles. Probably what I should do. So this is converting moles to grams, grams to moles. Let's say, okay, krypton. Actually, I suppose I'll just make up some stuff. Grams of, what do we want? Let's say carbon. How many moles of carbon? day than usual. Do you know what you do here first? What your first move is? You're gonna need to get some information from somewhere. It's almost always if you're at a table.